Okay, we're moving on to Unit 2 of functions. Functions is one of the most important units in my opinion. Other units such as the first unit you did, for the first, yeah. Unit 1 is mainly focused on defining terms. The important part of the unit is just memorization of the different terms and the methods we use to solve questions. Unit 3 is somewhat in a difficult sense since Unit 3 is trigonometry. And when it comes out difficult, it's very important, but it's not as a often used concept. And for Unit 4, it's probability and statistics, where understanding is the most important part of the unit. However, function is the most mathematical unit out of the all different topics that we're going to cover, and it's also the most frequently topics that are released in the tests. So I'll try my best to explain in the most easiest way possible, and I hope you guys can fully understand this topic. Let's see. As usual, the first thing we're gonna learn is the different terms. And for the different terms, we have relation and function. Now, these two are different things. A relation can be a function, but a function cannot be a relation. So, relation is any set of points which connects to two variables. As you can see, what this means that in a graphical way, you have more than one y value for one x point. As you see in this highlighted part, for one x value, we have one and two y values. So it says any number of inputs can equal any number of outputs. Yes. So it does say for relations is any set of points which connects to two variables. Uh, this is not necessarily true. I mean, you can write the definition as that, but obviously in a math question, it's not going to ask you for a definition question. They're not going to tell you to define what a relationship is. Well, in DP, business management or history, that's like 50% of your question. So what this is saying that if you have a graph like this, obviously this is a really bad graph. However, we know this graph is a relation because for each point, we have more than one y value for this graph. So basically any line or a curve in an x multiplied by y axis can be expressed as a relation. However, function has a specific definition. A function is a relation, so it's categorized as a relation in which no two different ordered pairs have the same first member. Now, this is a really, really confusing answer, but it's really easy to understand if you look at my friend's definition here. Look. So as you can see here, for each x value, there's only one y value. Sometimes the y values overlap, but not in the same x-axis, so it's okay. So basically, the definition of function is for each x value, there is only one y value. Like, for instance, this guy. This would, oh no, that's a bad one, sorry. For instance, this guy. This would be a function because for each x value here, we only have one y value. If there was another equation like here, because we have more than one y value for one x value, this would not be a function. So another example here, if there is a graph like this, this would not be a function. Why? Because here we have more than one y values. One, two, wait, no, I'll label it, well, I'll label that differently. One, two, three y values for one x value. So for a function, in order for a relation or a graph to be called a function, it has to have exactly one y value for x value. However, one thing to remember here, and as my friend starred, it says many inputs corresponding to one output is still allowed for a function. Now, what this means is that you can have a lot of y values having one x value, Like, for instance, this would still be a function. Because, like, if you look at here, this y value has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x values corresponding to it. However, this is still a function because for each x value, there's only one y value. As long as there's only one y value for one x-axis, the graph can be called a function. Obviously, you won't see this type of graph in your test, but it might come out in DP. Okay, now we'll be looking into function notations. In this, the machine, okay. Now, the easy way to think of this is looking back into the function machine as represented here. Uh, in this, uh, the machine multiplies the input by 3, then subtracts it by 2 before it releases it out in any output. So fx equals 3x minus 2. f of x is equal to 3x minus 2. Now, what this is trying to say is basically think of these type of things as a set of acts. For instance, you know how in a factory you have this type of conveyor belt which goes on, and then you have these type of steam machines that push, and then a circle suddenly turns to a square. Yeah, so basically this is how you think. Um, what we're putting in is x. So let me draw this in a bigger way. We'll call this a circle of x. But we want to make this into a square of, we want to make it into 3x minus 2. Then we need two steps in the middle, which is multiplying it by 3 and minus 2. By the way, this is not an x. It's not the variable x, it's the multiplication. So once it goes inside the steamed presser of 3x, it will become, let's say, a triangle. And this guy is going to be called 3x because now we have multiplied 3 for each variable. And then if it goes through this steam box, it will become minus, so every value is minus 2, so it becomes 3x minus 2. Like, this is basically what this type of function machine notation is trying to tell you in a nutshell. Um, let's look at the red notes. Not f multiplied by x. Also, other letters such as gx, hx, or even ht may appear depending on context. Don't confuse it, so just multiplying two variables. Now, what this is trying to say is that as it says, fx is just a notation that few mathematicians favor. Your professor in the future might call it hx. Your other professor might call it dx. This guy comes out a lot, by the way. And some people call it dt. Now, in this type of graph, the y-axis would still be y, but the x-axis will become t. So there would be a graph of dt, and this would be called dt. So the letters really mean nothing. Like the letter that comes here doesn't really mean nothing. And I think for your grade, you don't really need to care about the letter inside. I don't think you'll ever get a question that requires two variables, but sometimes the question might come out like this: ax plus b, fx equals ax plus b. Now here, a and b is not variables. These guys are constants. Now, what a constant is just a single number. So these are and an easy way to put it is that these guys A and B are just cloaked numbers. So like fx equals 3x plus 2. These numbers don't change, but x does depending on the x-axis. So don't confuse yourself with this. Just look at the notation, and if you want to know which alphabet is being used as the variable, just look at the alphabet inside the function notation. So this is one of the things you have to be careful. And then now cannot use function notations on a non-function relation. Yes, one thing for sure, you cannot call something fx when it's not a function. Like this guy. For instance, if I called it, I cannot call this function, I cannot call this graph fx because this is not a function. So make sure to do that. This is just definition, so make sure you get it right, or the IB hates you for writing function notation in a non-function relationship. And let's look at the practice question here. By the way, for each question, we have the page number written, and this page number also kind of introduces the unit. So if our explanation is too fast or you don't understand a certain thing, then I recommend you visit this page number of the Haese Mathematics textbook, because obviously these books are made by professors, and while they do use some difficult language, they still do a good job in explaining the concept. So if it confuses you, I recommend you go to this section of the book and try reading out the materials there. And if you're still confused, not if you're still confused, if you're trying to practice some things, I recommend you go to this page number and try out the questions there. I know Haese Mathematics has a lot of TZ questions, but those TZ questions become the steps that you're going to step when you're going to actually take the test. So I recommend you stabilize and make those steps strong so that you can get a concrete grade on your final eAssessment. Now, let's move on. For any function f, the value of the function when x equals a is given by fa. So for fx equals 2x minus 1, and f2 equals 2 multiplied 2 minus 1 equals 3. This indicates that the point 2, 2, 3 lies on the graph of the function. Likewise, if you put minus 4 in the function, instead of putting x, you would put minus 4 there. So this indicates that the point minus 4, minus 9 lies in the graph. Now, if I were just to quickly summarize the information here, you're going to get equations for a function. For instance, 3x squared minus 2x plus 1. Now, if the graph wants you to get f comma 2, the only thing you have to do is simply replace the x with the number they have given, and like this. One thing to make sure is that make sure you completely understand the equation, so that maybe you treat this like you square the whole value later like that. Maybe you can make some mistakes, but the simple way is just replacing every alphabet with the number they have given to you. And that's how you plug in to receive the y value. So this is technically the y value they're giving to you. So if I were to just finish solving that, it'd be 9. Yeah. So for this function, when x equals 2, y equals 9. So that's how you would get the values of the y value when you're given a function. Now, let's move on. Domain and range. Now, this is where the function unit gets a little interesting, and these questions are the most trickiest question you'll get when you go to your DP curriculum. I mean, for my opinion, they're tricky because they have so many confusing rules. But in your grade level, these should not be a problem. I'm sure these guys will not come out difficultly. Well, first, to understand what domain and range is, let's look at the definition that Haese Mathematics has set to us. The domain of a relation is the set of possible values that x may have, and the range of a relation is a set of possible values that y may have. Now, this is both for relation and function. I think these definition is straightforward. I will explain further as we look into some questions. Are there questions? Oh, yes, there are questions. All right. For functions, to find the domain of a function, we need to consider what values of the variables make the function undefined. Now, what this part of the notes is trying to say is that basically, if you want to find the domain, the first step is to find the undefined graphs. So in math, there are some values that are undefined. For instance, root minus 1. Now, some people may argue this is just I and call me stupid, but no. Because I's definition itself is imaginary number, it's technically a non-real number, so it is technically undefined. While, I mean, electrical engineers disagree, tell them to screw off because I do electrical engineering and they don't really use this as much. Anywho, and certain values like 0 over 1. Do you know this value? No, we call this undefined. If you're questioning like what is not undefined and what is not, use the calculator. Try to put the value, punch the value in, and then you'll get the result undefined. And then you'll know this part of the graph is undefined. So for instance, if you have a graph of 1 over x, basically the graph kind of looks like this. Oh, sorry. Me. You can notice how the value limitly goes to the top and goes to the bottom, but there is no certain value for 0. Why? Because for a 1 over x graph, oh yes, write this. 1 over x graph, in the x position, the y value is undefined because it's 1 over 0. So technically, this graph does not have a domain at 0. So the domain of this graph would be represented as now, this is a way you notate domain and range, but for your grade, you can just write it out, saying the x has all real values besides at point x equals 0. So at x equals 0, because the y value is undefined, we do not have a domain value. So it is out of the domain. Now, for certain graph, we can also think about the range. Now, I'm just going to erase this. And then I will be drawing a root x graph. So like this. I believe this is how it looks like. This graph is y equals root x graph. As I said before, since minus 1 is also considered undefined, this graph in this part of the graph, in the minus section, because these values are all minus root 2, minus root 3, these are just undefined. They don't exist. So the domain is bigger or equal to 0. But, however, you can also notice that this graph also has a range value. Because if you think about it, no number can be squared and result into a minus. So this graph can never go below this line, meaning the range is also bigger than 0. Now these are type of the range and domain you guys are expected to figure out, but they never come out as difficult. So if you just understand the concept, it'd be easy. And I'll give you a special case. Now what the special case is quadratic graph. Now you guys can wonder, isn't quadratic graph the graph that we always study? What's so hard about that? Well, quadratic graphs has a lot of traps. For instance, um, x squared plus 9. What is the domain for this graph? Obviously, it's all real numbers because there is no restriction. There is no y value that give you a undefined value. So any x value can give you a concrete real number value as y. Then why am I introducing you this? If you actually draw this graph, you can notice what I'm trying to say. And this point would be 9. Do you see what I'm trying to say? The y value never goes down 9 because 9 is always the set value and you always get positive number for x squared. So the range for this graph would be bigger than 9. So for certain quadratic values, they might have no restriction in the domain, but they may have restrictions in the range. So you guys have to make sure you don't make silly mistakes while solving this question. I recommend drawing every graph in order to understand the domain and range. Now, knowing this, if you read the notes, you can see how you get the domain. So it's bigger than 0 for all real numbers, and certain domains that give you -1 are ignored. Let's look at the note in red. The most common domain restriction are for the square roots and division by 0. Yes, the first two examples I've given is the most common ones, and these type of the questions are the difficult trick questions. So I just introduced to it, so you should not get it wrong. Yeah. And I recommend you give about like 10 to 15 minutes just to practice this understanding of domain and range and try the questions that is about in this page. Because these questions can be really tricky if you don't understand the concept well. Some questions also ask you these type of questions. So these are restricted graphs. These are not actual graphs that can be represented as equation. You can notice how in this part of the graph, there is a dot. Now what the dot means is that in that part of the graph, it's empty. So what it's saying is that it will never actually fully reach 5. So the domain would be from 1 to 5, but never reaching 5. So there is not an equal sign here. And for also the y value, it would be starting from -2, but not at -2. So -2 to 3, but without the equal sign here. Yes, this would how you would do it. And make sure you don't get confused with domain and range, and then you only write one side here, and you don't write it for the other side, like my friend. Now, he made a mistake there. Anywho, this is another type of graph, as I said. And yes, this is the graph I kind of told you to be careful, which is the quadratic graph, which has no restriction in domain, but does have restriction in the range side. So make sure not to make mistakes here, and then you guys would be okay. Let's go on. Most functions also have their unique ranges. Example, 2 to the power of x and 3 to the power of x. Yes, this is what this part of the note is saying, that certain graphs, as I said, has no restriction in the x value, but has restrictions in the y value. So 2 to the power of x graph, the graph kind of looks like this. And as you can see, there are real values for each x graph. So the x has a range, domain of all real numbers. But as you can see from the graph, it will never go to the minus side, so it's bigger than 0. Also, it is also bigger than 0 since no value actually gets to the power gives you a 0. As I said from the previous video, the most smallest number, 2 to the power of 0, is just 1. So this would never happen. All right, let's see the notation in red. Knowing how to use quadratic proposition to determine a quadratic function's domain and range is important. Yes, basically what they're saying is draw the graph out. Understand how to draw the graph, and then you'll see the range and the domain clearly. Next, we have coordinate geometry. So coordinate geometry can be represented in different coordination, obviously, since it's called coordinate geometry. And what this is trying to do is representing different positions using coordinates. Now, x and y can be only variables. Just know which is the input and output. So yes, this type of red note, what this is saying is that you might get a function in terms of y. Now, what this means is that you'll sometimes get a graph. I mean, IB never likes to do this. Like they always like to be linear with x and y, but sometimes they give you a graph where the y value is the x-axis and the x value is the y-axis, which is ironic because we still call it x-axis and y-axis. Yeah, just be careful of that. And these concepts are called quadrants. Now, these concepts are called quadrants. Now, what quadrants is, quadrant is basically the area inside your graph. So now using the x-axis and the y-axis as standard, this type of, here, the area, wait, no, I'll highlight this for you since it's really important to understand this. This part of the area is the first quadrant, and this part of the area is the second quadrant. This part of the area is the third quadrant, and this part of the area is the fourth quadrant. Now, what this part this says here would be introduced more in the transition section, but basically what this is trying to say is that um, any value in the first quadrant has to have both positive values for x and y. However, for the second quadrant, since as you can see, it's in the other side of the y-axis, all the x values here can be represented as minus, and all the y value is plus. Now, this is not just a tip. This is the standard fact. You'll always have minus value for x-axis and positive value for y-axis when you have a coordinate in quadrant 2. And same goes for quadrant 3, where we have both negative values. And for quadrant 4, we have positive value for x-axis and negative value for y-axis. Now the tip here says, if a question asks for coordinates, you must give an x comma y, not just x or y. Now, as I said, in DP, you have to use these type of notations to represent domain. However, as I said, in your grade level, you can just write it out. But for coordinates, that's not the case. For coordinates, it's important for you to write in this format, where you give the x-axis, x value first, and then the y coordinate. You shouldn't write it in a format saying x and y value is certain thing. So just make sure of that, and you guys will be okay. So the first thing you have to understand here is the Pythagorean theorem. Pythagorean theorem states here is that a squared plus b squared equals c squared, which means that c can be written in terms of root a squared plus b squared. This is simple algebra. Like if you put root on both sides, this gets removed together, and this stays here. So I think you guys can understand that. Now, what we're going to try to do is we're going to think as if these 2 points are triangle. You can see how the diagram already set a good example of having a right-sided triangle. By the way, Pythagorean theorem only works for right-sided triangles. So don't try that on a random triangle that looks like this and then say, why did I get a wrong answer or something like that. It has to be a right triangle. Yeah? So what we want to get is the d value here, the length between the 2 dots. And obviously the length is the most shortest distance between them. Now what we're going to try to do is we're going to try to get the x value here by thinking the first coordinate x1 and the second coordinate x2. So if we minus that, that would give us the distance here. Let's call that dx as in terms of distance d. Distance of x-axis. And then we're going to do y2 minus y1, which is y dy. Honestly, which comes first doesn't really matter because you're going to square anyways. So what I'm trying to say is you can do y1 minus y2, but you have to be linear in terms of both axes. What I'm trying to say here is you can do x1 minus x2 comma y1 minus y2. But you cannot do x2 minus x1 comma y1 minus y2. You can't switch them up. Like if you're gonna do the first coordinate minus the second coordinate, make sure you do that for both of the x and the y coordinate. Now, yes, as my friend here helped me, he wrote it in terms of equation, and now we're gonna treat this guy as like a and b here. So what we're going to do is we're going to square them together and then add them together and then root it, like exactly like this equation from the Pythagorean theorem. So some people say, like, shouldn't this be plus minus since we removed the square? Well, not necessarily, since we're getting the distance, and this can only be negative. Only be only be negative, can only be positive. So it only will stay as a positive root. And you can, yeah. All right. And then the tip here says, doesn't matter which order. Yeah, I kind of said that out loud. So let's go to a practice question. Find the distance between minus 2, 1 and b 3, 4. Now, you can memorize the graph and then just swipe right through it. But what I kind of figured out during your e-assessment is that normally you don't really have lack of time. Like time management is very important as you go to DP, but in your grade level, you actually don't have lacking time. You have enough, more than enough time. So I recommend for doing these type of graph coordinate distances. If you're the type of person who lacks in terms of understanding graphical and term function related things, I recommend you draw it out. So let's say 1, 2, this is minus 2, comma 1, so this is minus 2, comma 1. And then let's say it says for us to get 3, comma 4. 1, 2, 3. 1, 2, 3. Now see, that took me about less than 30 seconds. It's not really difficult to draw a graph, especially when you're doing it with hand. So I recommend, like, I know you guys take e-assessments through a computer. I recommend asking for a paper and a pen, and then you can just draw that out, swipe, swipe, and then represent it into a triangle as the diagram did, and then solve the question and just write the equation. That's all you need to do. So what I would do is I'll call this y2, x2, and I'll call this x1 and x2. So we want to do, no, not x2, y1. Now what we want to do is we want to do y2 minus y1, and we want to do x2 minus x1. Now this, oh yeah, remember to be linear. And how we would do this is just by plugging it in. So it's 4 minus 1, and this is 3 minus minus 2. Remember to keep the minus. This is a sincere value. And this would give you 3, and this would give you 5. So 3 squared plus 5 squared over root is d, using Pythagorean theorem. So d equals root 9 plus 25, which is root 34. Yeah, so this was how you would get the answer to this question. So straightforward, but a little teasy and a little difficult. I recommend you check it out on the textbook and practice a lot. Now, the next thing that comes out is midpoint, which gets a little annoying. However, midpoint is comparably easier to getting the length of the two different points. Now, basically what you can do is just this this equation, and you'll be easily getting the answer. Now, where did this equation come from? I'll just briefly explain it to you real quick. If you have 2 points, minus 1 comma 5, no, that can't be minus 1. Let's do plus 3 comma 5, and this be minus 2 comma minus 4. Yeah. If we want to get the midpoint between these two graphs, it'd be somewhere here, but we don't know it specifically. However, we know that this is exactly half of these two differences. Now, what I'm trying to say is each value of a midpoint is exactly between these 2 points. So you can just simply think of it as the difference between these two. No, the addition between these two over 2. And this would give you 1 over 2. So this coordinate would be 1 over 2 for x-axis, because that's what I did for the x-axis. And then for the y-axis, it'd be also 1 over 2. Wow, that is a miracle. I'm a genius. I'm just kidding. This has nothing to do with genius. So yeah, this is how you can get the midpoint, and it's fairly easier than the getting the length. But one thing to make sure is that you should not get the equations mixed between the midpoints and the distance. These are two separate equations, and they look fairly similar. So you make sure you don't get confused, and then try to get the length when they ask you for the midpoint. So yeah, let's see. This is a practice question, and I think you guys can try this out by yourself. Now next we have the gradient. Gradient is, in other words, also called the slope. And this term is going to be really, really frequently coming out. This term is going to frequently come out in DP when you do calculus. But in your grade levels, it's just simply rise over run, as my old math teacher, Mr. Collier, used to love to say. So basically, this is a difficultly written thing, to be honest, in my opinion, compared to how easy of what a slope is. Basically, slope is just rise over run. It's just how many x values you went over how many values you increased. So if you went two, if the x value increased by 2 and the y value increased by 5, the slope is 2 over 5. So this is an easy way to think of it. And the steps have here are distances. What this part of the red notation here is saying is that basically getting the slope is getting the slope of the graph representing the two distance between the two dots. So you don't need to get confused and just think of it as just rise over run. And oh, I didn't even see this part of the note and I knew how to write it. It's just simply the rise over run. And I don't think it's really confusing. Now, this gets a little confusing when you do quadratic equation, but that's for DP, so I'll just let you go with that one. Now, what's parallel lines? Parallel lines is basically graphs, lines with the same gradient. If you have the same gradient for the line, they are parallel. For instance, actually, I don't need to draw this. You can see it from here. The rise here, the run here is 1, and the rise here is 3. The rise here is 3, and the run here is 1. So they have the same slope, but they started at different position. So they're parallel lines. In this example, both lines have the gradient 3, so they're parallel. And here I'm just listing out terms to call. Like some question is going to ask you to get what is the parallel line of this graph, but starting at this by crossing this coordinate. Like I'm sure there's a question that's going to give you as a practice, but for instance, there is an equation called y is 3x plus 2, but we want a parallel line that crosses the point 1 comma 3, but be parallel with this equation. Now, since we know that parallel equations have the same slope, we just have to take this number and then bunch it up here. Y equals 3x plus b. But b here is not a variable, this is a constant. Then how do we get this value? We simply do it by plugging in this number. And then that will give you 3 equals 3 multiply 1 plus b. 3 equals 3 plus b, and 0 equals b. So we don't need a graph. We don't need a extra b. The only thing we needed was y equals 3x graph. And that would be the answer to the imaginary question I have just made up real quick. So these are the type of questions that you'll get. So you just have to understand the concept of parallel lines having the same slope. Now we have the units of perpendicular line. Now perpendicular lines are a frequently occurring topic, so you guys have to make sure you fully understand the concept here. Now the baseline of the concept as written by my friend here is that the gradients are negative reciprocals of each other. Now, what the reciprocals mean is simply just reversing the position of the numbers between using the fractional way. Now, what I mean by this, which is more easily explained, no, which is easily seen than explained. Now I have this number 5. Now, however, I'm going to write it in the fraction form, which is 5 over 1. Now, the reciprocal of this number, I'll just use r for reciprocal. R over 5 over 1 becomes 1 over 5. These two are reciprocal relationship. Now, the most direct method, obviously, you're not going to be asked to state what a reciprocal is, but reciprocal is taking a number in fractional form and flipping it. Yes, so we're technically flipping it based on this line. If we had originally 2 over 5, the reciprocal will be 5 over 2. So it's just flipping these numbers upside down. Yes, as example written here. Also, the negatives does not change. You have to make sure the reciprocal doesn't change any of the negative signs. It just changes your denominator and the numerator. How we can determine if a line is perpendicular to each other is that um, the slope of these two equations are in a reciprocal value, which is also in a negative way. Now, I'm going to say I have an original graph of y equals 3x plus 2. I don't know why, but 3x plus 2 is apparently one of the most frequently occurring number to me. And now I want to determine the parallel graph to this original graph. Now, as my friend wrote here, the gradient of the parallel graph are negative reciprocals of each other. Now, what this means is that, as I stated before, the reciprocal, not the reciprocal, the slope of a graph is the number that is written in front of x. So in this case, it's 3. However, because we have to get the negative reciprocal, I'm going to write 3 in a fractional way, which is 3 over 1. As I said before, the reciprocal would be 1 over 3. However, notice how it says it's a negative reciprocal. So we have to put a negative right here. If this concept is very difficult to you, think of a way that if you multiply the gradient of the original graph and you multiply the slope of the parallel graph, it will always turn out as minus 1. This is how an easy way you can check if you have the right gradient. So this parallel graph is going to have a slope of minus 1 over 3x. And obviously the intercept doesn't matter because we're just finding the parallel graph. Often the question is going to give you a point that the parallel graph passes. For in this case, I'll just say 1.6. Wait, actually, let's not say 1.6. Let's do 6, 1. If these graphs are giving you the sign of the y-intercept that is unknown, that is unable to be figured out using only the original graph. So because this graph is passing 6, 1, I'm going to put it into the values, and that would become this way. Now, this is just one variable equation, so we can easily understand that the y-intercept is b. So the graph would turn out the parallel graph to y equals 3x plus 2, and that passes 6, 1 would become y equals minus 3 over 1x plus 3. Yeah, this is a concept that, as I repeat, that frequently comes out in tests. So please understand that in a parallel graph, the gradients are negative reciprocal to each other, or if you multiply the original graph and the gradient of the parallel graph, the value always comes out as minus 1. I'll give you a big star here. Now we'll be moving on to quadratic functions, and this is kind of the key unit out of the unit 2, which is functions. So this is the key component of functions. Now, first of all, you have to understand the properties of a quadratic equation where it explains equations of the form ax squared plus bx plus c equals 0, where a is not 0. This is very important. I'll explain why later. Are called quadratic equations. They have 2, 1, or 0 real solutions. Now, this is real. This word real solution is not really important at your level yet, so you guys don't really need to think about it yet. So a quadratic function is a relationship between two variables which can be written in the form of y equals ax plus bx plus c, where x and y are variables and a, b, c are constant, where a is not 0. Now, like why do we have to have it in the format of ax squared plus bx plus c? Now, why do we need to have the fact that a is not equal to 0? Now, the word quadratic, okay, before I explain what quadratic equations are, we have to first listen to like why we call these type of line graphs linear graphs. They're linear because they're literally linear. They increase in a certain value at the same rate. However, quadratic graphs are kind of different because they have this guy right here. We have a x squared in the function. Now this it means that the graph increases exponentially, and that implies that it's a quadratic equation. So we always have to have this x squared. This is what makes a graph quadratic equation. But if the coefficient of x squared is, for instance, 0, then this variable does not exist, so it just becomes a linear graph. To prevent that, a always has to have a value that is not 0, a real value. Wait, actually not real value, but it has to have a value that is not 0 in order to be a quadratic function. Now we'll look into the graphical properties. Just now, the thing about this graphical properties is that it has a parabola shape. Now, what a parabola shape is that it's generally looks like a graph like this. Of course, you can have a graph that looks very long, but this will still have a parabola shape, so it's a quadratic equation. And it is symmetrical on an axis of symmetry. We'll obviously go over more into in depth of what this means, but the download is that in a certain point, the graph is literally identical, symmetrical between left and right of this specific position. Now it has a vertex. Now what a vertex is it's this point right here that's in purple. I'll leave it purple because purple is a better color to recognize. And what the vertex does, it's showing the minimum or the maximum point of a quadratic equation. I will again look more in depth a little later. Don't worry, it's gonna come out. Now you can think what is an imaginary number, but sometimes the x-intercept can be an imaginary number, a number that does not exist. Especially looking at this type of graph right here, you can see how there is no intersection between between the x-axis because we know that the graph is going infinitely above but never down again. So sometimes the graph does not have an x-intercept, but it always has a y-intercept. So make sure of that. Now this is a unit of vertex form, and this is a different form of representing a quadratic equation. Normally, I said we represent the quadratic equation this way, which is y equals ax plus bx plus c. This is the general form. However, there's a thing called a vertex form, which is very useful for finding the vertex, literally. Now, the vertex form has the shape of y equals bracket x minus h close bracket to the power of 2 plus k, and have the same shape as the graph of y equals x squared. The graph of y equals x squared is translated through h comma k to give the graph of y equals x minus h squared plus k. The vertex shifted to hk. Now, what this is trying to say, it does sound very complicated, but it's actually very easy. I'll try to explain it in the easiest way possible. So, the rule about y equals this type of vertex form is that it starts from y equals x squared graph. Now, this is y equals x squared graph. But if we translate this in, for instance, 2 comma 3, in this case, I'm trying to give a number for h and k. So h is 2 and k is 3. If I translate it in 2 comma 3, I would move it right twice. So this is 2, and then I'll move it 1, 2, 3. Now this is 3. So the graph would translate this way, creating the graph of y equals, because h is 2, x minus 2. Actually, I'll make it, I'll move it a little more so that you guys can easily see it. There we go. That's a little better. So 정리 좀. All right, here, as you can see, this graph would be y equals x minus 2 because we want to do minus h plus 3 because k is 3. So you can see how the y equals x squared graph translated directly 2 comma 3. So this type of graph directly shows you what the vertex is, and at the same time it gives you what type of graph you are drawing. And these vertex points are very important because a lot of the question when they ask you to draw the graph, they ask you for three things in general. They ask you for the x-intercept, which is sometimes does not have. In that case, you can write invalid or imaginary. And then you get the y-intercept. This is easy because you just have to plug in 0 to any type of form you have. And then it tells you to get the vertex point. And the vertex point, as I said, is the maximum or the minimum point. Now, why? You guys can literally see why I call it the minimum point, but why the maximum point? Because sometimes the slope has a trend of y equals minus x squared when the graph looks this way, which is concaving downwards, showing that the vertex point here is the maximum point. So the vertex point generally shows the maximum point and the symmetry point where the graph is symmetrically equal using that point as a base. And to get the vertex equation, and to get the vertex point, you have to put the graph into the vertex form. And creating this vertex form can be very, very tricky the first time you learn it. So if I were to ask you to practice many questions, I would tell you you have to practice this unit a lot. And one thing to make sure is that the a from ax squared minus k plus, again, I'll say it. And then one thing you have to make sure is that sometimes the graph is not translation of y equals x squared. Sometimes there's an a in front, which is y equals ax squared. That's what the textbook here is saying. And this type of graph is still the same, but you have to make sure that if you want to change these type of graph into vertex form, you always have to take the a out of the whole bracket before you turn it into a square version. I'll show you an example if there's a question below. I think there is, so I'll do it later. Okay. If not, I will do it in the middle so you can just skip towards that part. Now going down, we have summary of vertex form properties. All right. This is just a quick property. Vertex if a is bigger than 0, so now we're talking in y equals a x minus h over square plus k form. Now if a is bigger than 0, the vertex is the minimum point. If a is lower than 0, the vertex is a maximum point. K represents the vertical translation, so this kind of represents how much your it kind of tells you the y coordinates of your vertex point, and H tells you the coordinates of your vertex. H tells you the x coordinates of your vertex point, but you have to make sure you put the minus here, so you don't get the sim. Oh, minus plus a sign. You don't get the signs mixed. And there's a thing, there's this written down here, but this is not as important, so you guys don't have to consider this a lot, but just know that generally, if the a is lower than minus 1 or bigger than 1, it's thinner than y equals x squared, and if it's not, it's wider. Normally, the question doesn't ask you, and even though it does, you can just quickly try to draw out the graph, and then you'll know the results anyways. Nobody actually memorized that to get a full mark in the eAssessment. Now, x and y intercept. Oh gosh, I've been explaining x and y intercept before, like even I introduced to you. But at this point, I'm sure you guys should at least get a concept of why what the x and the y intercept is. X-intercept of a function is the value of x when the graph meets the x-axis, and y-intercept is a function that when it's the function y-intercept of a function is a value of y when the graph meets the y-axis. So yes, can you see in the diagram, this is the y-axis and two x-axis. Generally, the y equals generally the quadratic equation tends to have two, one, or zero x-intercepts. Now this will be further like explained when I start explaining b squared minus 4ac. But yeah, that will be a future thing. So just sit and wait. And just generally, I don't think I have to explain a lot about x-intercept and y-intercept. If you just plug in zero on, if you make the y become zero, you get the x-intercept. If you plug in zero to x, it gives you the y-intercept. And I'm sure this is a pretty straightforward question, but one tip I would give you is that never underestimate these type of questions, because if you lose marks from these easy questions, it's going to be really difficult to get a good grade. For a quadratic function, the form of y equals ax squared plus bx plus c, the y-intercept is the constant c. Obviously, because y-intercept is the value you get when you plug in 0 to the equation, and it's a0 squared plus b multiplied by 0 plus c, so y equals c. So the y-intercept becomes c. As you practice the questions, this skill is going to naturally come to you anyways, so you don't really need to try to memorize that in the form of ax squared plus bx plus c, it's the y-intercepts are always 0. And one common mistake I'm going to point out is that people mistake this y equals ax squared plus bx plus c form and this vertex form. In the vertex form, even though you plug in 0, it will give you the y-intercept, but k is not the y-intercept. K is the y value of the vertex point. So never confuse yourself with k and c. You have to understand the form you're using very, very thoroughly. So we'll move on to how to find the x-intercept. In general, because we're trying to plug in 0 into the y, if you have an equation in the form of y equals ax squared plus bx plus c, you can just put it in the form of 0 equals ax squared plus bx plus c, and the x values you would get would be the x-intercept. This only works because y is alone in its own area, and for instance, if the graph is like y over x minus 2, obviously equals x plus 2, obviously putting 0 on the whole thing and then saying 0 equals x plus 2 is not the way you get the x-intercept. You're thinking that you plug in 0 in the y, which actually ironic sense works here, but this is a special case. And yes, the graph can cut through the x-axis twice. The graph can touch x-axis once when in this case, you only have one x-intercept value, or you might have no x-intercept value. Now let's try a practice question. Let's see. Find the x-intercepts of the quadratic function. Make sure you understand what you're getting. Don't try to get y-intercept when the question asks you for the x-intercepts. That's a mistake I used to make a lot. So because we're getting the x-intercept, we want to plug in 0 to the y. So it would become 0 equals x squared minus 6x plus 9. And in unit 1, I told you how we can solve these type of quadratic equations. In this case, I'll use the cross sign method, which is this way. I'm going to sort it out, and then I would think it's going to be x minus 3 multiplied by x minus 3, which is x minus 3 to the power of 2. So it would only go through the point of 3, 0 as x-intercept. Well, it kind of wrote 3 there, but it's better to write it in the coordinate form. And then we have y equals minus x squared minus x plus 6. Again, because we're trying to get the x-intercept, I can plug in 0 there. Minus x plus 6. Did I write that down right? Yes. And I plug in 0 here. And then now that I plug in 0, I tend to have this like a tradition, or like this is a type of manner that people have in mathematics. You kind of never let the first coefficient have a minus. So I'm just gonna put minus on the whole equation. And because minus 0 and 0 is the same thing, I can just write in the form of 0 equals x squared plus x minus 6. Again, I'm going to use the crisscross method. Minus 3 plus 3 minus 2. Now this, again, you don't have to be hasty about not having this skill thoroughly. You just have to keep on practicing and making this skill embedded into yourself. This way you will come out naturally. And now the equation can be written as x plus 3. So the x-intercept is going to be 2 comma 0 and minus 3 comma 0 as written in the answer. Yes. Let's look at the red notes here. If a is a negative and other sides of the equation has 0, just remove the minus by flipping the sign of every term. Yes, this is what I was doing right here, actually. Yeah. I'll highlight this for you. Wait, actually. Yeah, never mind. And then this form of a multiplied by x minus alpha multiplied by x minus beta equals 0 is very common when solving a quadratic. Know it well. Yes, this just generally means this is just solving general quadratic equation. So learn and practice the best you can. Let's look at another red sign here. You might also be asked to use other methods of solving quadratic from Unit 1. Yes, make sure to look back on the videos we made for Unit 1. It's obviously the video is pretty long, so just look at the solving quadratic equation sections and you'll learn what type of methods you can use to solve the quadratic equation. Now, all right, so what we're trying to do here is that we're trying to solve this equation of y equals x squared minus 2x minus 5. However, just by looking at it, I can't see the crisscross method to solve this equation. But in Unit 1, on the video of Unit 1, we learned a different method to solve quadratic equation, which was using the quadratic formula. Now, again, because we want to get the x-intercept, we can plug in 0 to the y. A solution of a quadratic equation can be written in the form of minus b plus minus root b squared minus 4ac over 2a. So in this case, a is 1, b is minus 2, and c is minus 5. So if I write that real quick, obviously, in the test situation, you don't have to write out this elaborately, but if you're a type of the person who is very hasty and you make frequent mistakes, I hope you write down the whole steps because that's gonna help you for the future. Now, if you simplify this, this will become 6, which is exactly the same as the answer. So this is another way you should keep in your mind. Just know that quadratic equations may take a long time, but it's always the right answer. It's just that sometimes you make silly mistakes, so never use the quadratic equation first. Always try the crisscross method, and then if you feel like it's not going to work, just use the quadratic function. Now we have the axis of symmetry, as I mentioned before. The axis of symmetry in every quadratic function, in every quadratic function, the axis of symmetry is at a certain x-coordinate. So the properties of axis of symmetry is that only one exists per quadratic formula. X-coordinates of the axis of symmetry is the x-coordinate of the vertex. I kind of implied that before. And if there are two x-intercepts, the axis of symmetry is at the midpoint between them. Yeah, okay. All right, I think looking at the example is gonna best help you understand. Apparently, my friend made this graph and is very proud of it. Yeah, hooray. So the example quadratic equation he wrote is 0.2x squared plus minus 2.4x minus 2. And the vertex coordination, which he wrote down very difficultly. Okay, this might look very confusing at first sight, but I'll just try to make you a little better. Now, I'll first explain what minus b over 2a is. So the minus b over 2a is generally the equation you use to get the vertex point when you have an equation in the format of ax squared plus bx plus c. So I can drive you this formula right now, but I don't think that's really necessary when you have the vertex form equation. So don't get confused. Just generally means that this point is the x coordinate of the vertex, and f minus b over 2a is just using the function plugging in the vertex point to get the y coordinate of the vertex. So this point, which is apparently 6 comma 9.2. And then the axis of symmetry is obviously x equals minus b over 2a because the x coordinate of the vertex is minus b over 2a. Now this is a graph. I think this thing is pretty straightforward, but if it's still confusing for you, I recommend looking at the Haese Mathematics notebook to try and practice. Vertex is a very frequently asked question, especially in your grade. So make sure you understand the concept fully and you're able to answer all the practice questions in the Haese Mathematics. Now we have the final section of our chapter of functions, which is the rational function. And I have to say, this does require a little bit of memorization. So follow through with me, and this will try to clear your minds on what the rational functions are. First of all, rational function, we have to first look into the definition where rational literally means the fraction. So functions that have um, 미안해, 다시 할게. So rational basically means fraction, and what I mean is that fraction functions, not like y equals 1 over 2x. This is not a rational function. It's when the x, the variable, is physically below in the denominator section. So any function that can be in the form of fx equals fx fx equals px over qx, where p and q are polynomials. This is not necessarily true, but definitely qx always has to be a function, but px wait, that's a really bad writing. But px can be just constant. So y equals 5 over x minus 2 would also still be a rational function. However, in MYP, you're only required to know rational functions where P and Q are linear. Oh, yes. So sometimes in the DP level as you go, you'll get functions like these things. But obviously, because you guys are still in MYP, you guys only have to think about PX and QX always being linear functions. All right, so we have a good example here. And fx equals 2x plus 3 over 5x minus 4. So this diagram's a little written in a confusing way, but don't worry. I'll just put a 1 here to notice that these two are not the same function. My friend just wanted to give you examples of what a rational function can look like. So this is one of the rational function. This is pretty straightforward. But sometimes rational functions are given in a format where there's a constant in front. So for instance, y equals 7 minus 2x plus 1 over 5x minus 4. What my friend wanted to show you here is that these can be written in the full rational function way, which is 2x plus 1 over, so I'm going to assume the denominator here is 2x plus 1, so I'm going to do 7 multiply 2x plus 1 minus 2x plus 1 over 5x minus 4. Now that the denominators are all the same, we can simply do addition and plus. So 14x plus 7 minus 5x plus 4 equals 2x plus 1 over 9x plus 11. Yep, that's how. Oh, by the way, you have to do this when you're finding the x-intercept and vertical and horizontal asymptote and sketch basic shapes. So the reason why you have to do this is this shows the clear diagram, and that's needed when you're trying to find these things. So normally these type of rational function questions will ask you about how to find the x-intercept, the vertical horizontal asymptote, and how to sketch the basic shapes. Now let's start with the y-intercept. Y-intercept and x-intercept is pretty straightforward. You just have to plug in y equals 0 for x-intercept and x equals 0 for y-intercept. These are pretty easy if you don't necessarily even have to change this format if you have this type of equation if you're trying to get the x and the y-intercept. So that's fine. But for the vertical and horizontal asymptote, I guess you do need um, this type of graph. So the first thing you need to know about what a asymptote is the asymptote is basically an equation of line where the graph will never actually meet. So for instance, let's use the example my friend gave here. So the graph we're given is, okay, y equals 2x plus 3 over 5x minus 4. Now, in this graph, I want to first ask, can we have a 0 in the denominator? Is there a thing called 1 over 0? No, this is always shown as invalid, mathematically unable to describe. So we're assuming that this graph will never reach this point. Now, that is the horizontal asymptote. So that is the vertical asymptote. That is the vertical asymptote. So we're assuming we cannot put the value x equals 5 over 4 into this. The graph will not have a value for x equals 5 over 4 because if we plug in 5 over 4, the denominator is going to become a 0, and that means the graph does not exist. So as you can see, this is how the graph of y equals 5x minus 4 over 2x plus 3 looks like. And as you can see in the section of, this is 5 over 4, by the way, because there's 5 squares and that's 4. There is no single value here. The graph just not simply has a value there. And then how do you get the vertical asymptote? Now that's actually there's many difficult ways, and my friend here used the limit way, which is pretty DP-like, but don't worry, even though it's DP-like, it's not difficult. What we're doing is the vertical asymptote is basically the vertical asymptote is basically the value of the graph when it reaches infinity. The value that graph wants to reach as it goes to the infinity. So what we do is when we have this type of graph of y equals 2x plus 3 over 5x minus 4, we simply plug in infinity. Now you guys are gonna start questioning me and asking me, wait, isn't that just infinity over infinity? Yes, that is true, but in the mathematical law of convergence, the value actually has a number. So this if we plug in infinity, the graph will look like this because yeah, but plus 3 and minus 4 are just too minor, so we can ignore these things because they're minor. I mean, in front of infinity, this plus 3 and minus 4 are going to make a difference. You guys probably heard from your childhood memory that infinity plus 1 is still infinity. Yeah, so these can be ignored. And then you have these y equals 5 infinity over 2 infinity. And you guys are going to ask me, so aren't the 5 and the 2 also going to be ignored because it's minor compared to the massive number of infinity? Well, no, because infinity itself is still a numerical value. Infinity by definition means a number that is too big so we cannot express it. So if we multiply 5, there is a difference. So we can think of infinity as an actual number. So these two cancel out, and the graph becomes 5 over 2. So the horizontal asymptote becomes y equals 5 over 2, as can be seen in the graph itself. This is very confusing. I understand because this brings in the concept of limit, which you learn as you learn derivative in DP second year, especially if you're in SO. But uh, this is a small like a tip to solving this question, so it shouldn't be that as confusing. You just have to plug in infinity, ignore the small numbers that feel like they don't matter anything. Sorry, you guys are just too small, and then cancel out the infinity and have the leftover. That's the horizontal asymptote. Now the final thing that was in the graph is the sketch, the basic shape. Honestly, the only thing you guys have to remember is this weird like shape. Now you got this weird like, I actually have no idea how to call this, like uh cross waffle shape. Yeah. And now sometimes people ask, how do we know if the graph looks like um this or like this? Now that can be easily seen through the x-intercept and the y-intercept and the asymptotes. For instance, if you're looking at this graph, the x-intercept is, I assume that's -4/3. No, that's a y-intercept, and the x-intercept is -2/3. And we know that the vertical asymptote and the horizontal asymptote is right here. With the basic knowledge that the graph always has to be on the first and the third uh, quartile, or second on the second and fourth quartile, we can simply understand that these intercepts cannot exist if we're trying to draw a graph on the second and the first quartile. Because if you think about it, the graph cannot pass these lines. These lines are like barriers. You cannot pass them. So if I draw it like this, I wouldn't be able to pass minus 2/3, 0, and 0, -4/3. So with the knowledge of the x-intercept, the y-intercept, the vertical asymptote, and the horizontal asymptote, you can just draw these, as I said, munched waffle shape uh, with the given information. Now let's look at what my friend wrote here. There are these four pieces should be enough for you to sketch. Plot the intercepts, paths, and the asymptote line first. Yes, you always have to get the information first in order to draw the graph. Then linear rational functions are either increasing or decreasing. So the blue one's increasing and the red one's decreasing. You can tell which shape it is by plugging in two values, f0 and f1, and seeing if the value increases or decreases. Okay, this is a also good way, but I personally like my way because it's pretty straightforward. And no, I gotta say, while my friend's way is more correct. That gives you the more direct value. But if you accidentally memorize the shape of increasing and decreasing wrong, that's a big failure. That's a sad failure for you. So I honestly just like to say, just roll with the situation. Using the information of the intercepts and the asymptotes, draw the graph out, and you'll probably be able to see if it's a decreasing graph or increasing graph. But just in case the question asks you if it's a decreasing graph or increasing graph, I recommend memorizing the shape. I mean, it's pretty easy. Like if you just draw a line, as the x value increases, you just know that the y value is decreasing if it's a decreasing graph, and it's increasing if it's an increasing graph. Now then, you draw a curve. Oh, that's a better word. It's a curve. All right, my bad. Draw a curved slope based on if it's increasing slash decreasing, passing through both intercepts, as I mentioned. This was this was the kind of the way that I introduced. And make sure nothing passes through the asymptotes. Yes, nothing ever passes through the asymptote graph. If you like, in the middle of the solving these type of rational function, and you just notice that the graph value um, goes through the asymptotes, check if your asymptote values are right, and then if they're right, your graph's wrong. All right, and they don't need to be exact. You don't have to make a concise value that at x equals 0 point minus 0.3, there has to be an exact value of I don't know, minus 1.23. No, you don't need to do that. Just pinpoint, but they always have to go through the intercepts. So pinpoint the intercepts and then draw a curve passing them. So they don't have to be exact, especially this side where it doesn't have any information about. So that's the whole unit of functions in a nutshell. And the thing about the unit functions is that it's honestly the most frequently occurring topics.